This is a Heathkit model C-3 condenser checker. Take note, it says condenser. That's the old term for capacitor. I will use the term capacitor checker from here on out. I recently rebuilt the unit. It's got all new film caps in it. It is working very well. I am demonstrating this unit in somewhat dark lighting conditions because on camera the tuning tube looks a lot better, and in the broad daylight using a camera it doesn't really show up that well. Take note, I'm wearing gloves because when you're doing a leakage test there's a significant amount of voltage going across these two terminals. Be safe, it's best to wear gloves. I'm going to start off by testing a brand new capacitor. This is a film cap. It's a 0.1 at 630 volts. I want to show you how the tuning tube works on a brand new cap, so then you can get a good idea of the difference between a new cap and some of the old caps that I'm going to be showing you. So to test a film cap, you want to be on the paper and mica selection. Paper and mica means film. And up here is for electrolytic caps. So we want to be on the paper and mica. There's a nice click stop to tell you that you're there. You want to be on the selection of 0.1 to 50 microfarads. And to get the value, we sweep the dial until we get the most open condition. And I don't know if you can see that on camera, but that is exactly on 0.1. I'll move this away so you can see it. There's 0.1 underneath there. It's really, really accurate. This little checker amazes me with its accuracy. So now we're going to do a leakage test. I need to give you some background on leakage. Leakage does not mean fluid leaking out of the cap. What leakage means is that when you have DC voltage passing across a capacitor, the capacitor is said to be leaking. Capacitors should block DC. Capacitors should allow AC voltage to go through. So when you have DC voltage going across a capacitor, it is said to be leaking. So we're going to test this 0.1 at 630 volts at 25 volts DC potential. In other words, we're going to put 25 volts or so across this capacitor to see if we can, in essence, push DC through this capacitor. So we flip it to the leakage test and it recovers and it goes back to normal, back to the open condition very quickly. There is no leakage on that cap. You will see in a brief moment what a cap looks like when it's leaking. It will not recover, it will not even open up, or it will open up very slowly or open up very little. So now we're going to go to, let's just do 250 volts because after all it's a 630 volt cap. Do the leakage test. It opens up quickly and it opens up very, very wide. There's no leakage. We're going to go all the way to 450. Again, it opens up great. There's no leakage on this brand new cap. We would not expect it to be leaking. So with that said, we'll now get an idea what caps look like on the leakage tests if they're not all that great of a cap. In other words, they're leaking DC. So you want to pay attention to polarity on an electrolytic cap. This is a old 50 microfarad at 150 volts. Again, you got to be careful with polarity. And we turn it to the electrolytic selection here, which is in this scale. We do not want to be on paper and mica. And it's a 50 microfarad, so we select 0.1 to 50 microfarad. And we sweep our dial and we get the most open condition. That's basically the most open condition, and it is above 50 microfarads. That makes sense because old electrolytic caps commonly go up quite a bit in value, and I will show you this value on a DVM in a moment after I conduct the leakage test. So we're going to do the leakage test. We're going to try 25 volts potential across this capacitor. Watch the tuning tube. And now you can get a sense of how the cap is causing this tuning tube to open up slowly and not as wide as the original condition. There's the original condition. And there's the leakage condition, and it is leaking DC. You see, after a while of getting used to how the tuning tube reacts to certain caps, you'll get a good idea as to whether a cap is leaking or not. So we're going to go to 150 volts. Bear in mind this is a 150 volt capacitor. It's definitely leaking. Okay, it's open very little. I don't know if you can really even per se see that on the camera all that well, but there is an open line, but it's very narrow, and it did it slowly. This is a bad cap. It's definitely leaking. So now we're going to go to a film cap. These two caps were in parallel. They actually came from this unit. They are 1 microfarad at 600 volts. They are a film cap, so we're going to go back to the film cap setting, paper and mica. We do not need to pay attention to polarity since it's a film cap. I'm going to just test one of them. They were actually in parallel to equal 2 microfarads. 1 microfarad caps equals 2 microfarads when they're in parallel. So now we're going to select 0.1 to 50 microfarads. We're going to sweep our dial. Maximum opening. And it's like almost dead on 1 microfarad on the dial. This little checker amazes me sometimes. It's amazing how accurate this thing can be. It's very close to 1 microfarad. Now we're going to do the leakage test. We're going to do 25 volts. And it opens slowly, but it does open wide. I'd say maybe a little bit of leakage. I'm going to go to 150. Kind of slow, but it does open. 250. I would say we're really starting to leak at 250. It's not opening as wide. It's getting slower. 350. At 350 volts, it's opening just a little bit, and it was quite slow. Now you might get an idea now that as we go up in voltage, we are increasing the DC potential across that capacitor, and eventually it's going to start to leak. In other words, the more DC voltage we have, we're kind of like trying to drive that DC voltage across that cap. And eventually, the cap is going to start leaking. I mean, the question really is, can the cap reject the amount of DC voltage that we're trying to push across the two terminals of the cap up to its rated voltage at, let's say, just 600 volts? Can the cap reject DC voltage all the way up to 600 volts? Well, in this case, you know, we kind of saw it not being able to reject it even at like 250-ish. By 350, it could not reject that level of DC potential. And I'm going to now test a resistor. To test resistors, we need to change the lead over to the resistor side. And we need to switch over to the R. We sweep our dial till we get our most open condition. And it has landed extremely close to 10,000 ohms. And we can go to the R times 100 selection. We go back to here and get our open condition down on the left side of the scale. And it's like dead on 100, but remember we've got a multiplier here. It's R times 100. 100 times 100 equals 10,000 or 10K. This is a very accurate resistor. This resistor is actually very close to 10K. Again, this little checker really amazes me. So there you have it. I think the real benefit of this checker is the leakage test. It works very well. It's a very handy item to have around if you're doing vintage electronics work. Thank you for watching.